In today's lesson, we're going to be writing equations of polynomial functions. So let's get started. The directions say to write the function represented by the given zeros or the polynomial graph. Let's start with number 1. I'm going to do the odd problems and leave the even problems for you to use to practice. At the end of the video, I'll reveal the answers to the even problems. Number 1. Before we start number 1, we're given -4, -3, and -2. Those are the zeros of the function. So you're either going to be given the zeros or you're going to be given the graph. In problem number 1, we're given the zeros. So the factors that we would have with those given zeros would be x plus 4, x plus 3, and x plus 2. Remember that the zeros and the factors are opposites. So if you're given a -4, then your factor is x plus 4. If you were given a +4 as the zero, then your factor would be x minus 4. Okay, now we're going to do the work. So the work part is we're going to multiply out these three factors. So we're going to multiply x plus 4 times x plus 3 times x plus 2 so that we can get the standard form equation of the polynomial. Let's begin. We have three factors that we're multiplying. So we're going to start with just multiplying the first two factors using FOIL. So FOIL says first terms x times x is x squared. Outside would be x times 3, 3x. Inside is 4 times x, 4x. And last is 4 times 3, positive 12. And we are going to be multiplying that with x plus 2. Before we multiply that with x plus 2, I see that we have some like terms here, so we need to simplify that. We'll have x squared plus 7x plus 12, and multiply that with x plus 2. Okay, so in order to multiply this, we're first going to multiply x squared times x, which is x to the third power, x squared times 2, 2x squared. Now we are going to do a similar step. We're going to be multiplying the 7x with x, so that's 7x squared, and then 7x times 2 is 14x. And lastly, we're going to multiply 12 times x, 12x, and 12 times 2 is 24. So hopefully you understood what we did there. We just took the first term in the first polynomial and multiplied it by this term and this term. That gave us this. Then we took the next term, multiplied it by these two again. That gave us this. And then the last term gets multiplied with these two again, and that gave us this. Okay. Now we want to combine like terms. So we have like terms 2x squared and 7x squared. These like terms combine to make 9x squared. And then we also have 14x and 12x to make 26x. So our final answer is f of x is equal to x to the third power plus 9x squared plus 26x plus 24. And as you can see, it is already in standard form. So we're now going to sketch the graph. Now, in order to sketch the graph, let's go back to the beginning. We know that the zeros were -4, -3, and -2. So the first thing I'm going to do is plot the zeros on the graph. I'm going to use another graph here that actually has numbers on it. Okay. All right. So we're plotting the zeros of -4, -3, and -2. Those are the zeros we were given. Okay. Also, let's remember the word multiplicity. Each of these zeros have a multiplicity of 1. We know that because it doesn't say otherwise. Sorry, multiplicity of 1. It doesn't say otherwise. If it weren't a multiplicity of 1, it would have to say that the 0 has a multiplicity of 2 or has a multiplicity of 3. It would have to state that in the problem. So we are okay to assume that the multiplicity is 1. So remember that when you have an odd number multiplicity, that means that the graph is going to go directly through that 0. So let me sketch what I mean by that. So either our graph is going to be coming from above and going down right through the -4, and then back through the -3, and then back through the -2, because the multiplicity is 1 for all of these zeros. So that means the graph should go straight through. So we could have this situation, or it could come right from below, or increasing from below, going through the -4, then back through the -3, and then back through the -2. So these are the two types of situations we could be in. How do we know which one we are dealing with? Well, that is end behavior. End behavior. If we know how the ends of the graph look, then we know where to start it and where to end it. So, end behavior depends on the degree and the degree and the leading coefficient. Let me just write LC. Save time. Okay. So the degree of our polynomial is the highest exponent, so the degree is 3. And the leading coefficient would be the coefficient attached to the highest exponent, so the leading coefficient is 1. So in the end behavior chart that you saw in the last video, you should be looking for a odd degree and a positive leading coefficient. So we have an odd number for the degree and we have a positive number for the leading coefficient. So hopefully you're currently looking at the chart. I'm going to bring it up here to remind you. We are in this corner of the chart. The top left, odd degree with a positive leading coefficient. So as you can see in that sketch there, the end behavior is that as x approaches negative infinity, which would be the left side of the graph, the end of the graph should be pointing down. So y should be approaching negative infinity. And on the right side, when x is approaching positive infinity, your graph should be pointed upwards, which shows that the y values will be approaching positive infinity as well. Okay? So let's mimic that when we sketch the graph. We should be starting on the left side, pointing downwards. So something like this, right? But on the right side, as we are finishing the graph, should be pointing upwards. Something like this. Okay? And we want to make sure that we go straight through those zeros, right? A multiplicity that is an even number would not go through the zeros. It would go toward the zero and then touch the zero and go the other direction. But since our zeros have a multiplicity of 1, we're going to go directly through, back down, and back up. Okay? Before we do that, one last thing to notice. Our y-intercept is 24. So if we had 24 on the graph here, if we had enough space to plot the y-intercept of 24, you would have to do that. Okay? All right, so drawing the graph, we're going to make sure that on the left side, the graph is pointed downwards. We're going to go up through the 0, back down, and back up. Now remember that this is just a sketch. This is not completely accurate. If we wanted to make the graph absolutely accurate, we would need to substitute in some x's, some x values, so that we can get the corresponding y value to make an accurate point. In one of the previous videos, you learned how to evaluate polynomial functions using the Desmos scientific calculator. That is something that we are going to do when we get to problem number 3. All right. We are given the zeros. Oh, actually, I want to do a problem that has multiplicity. So we're going to skip number 3 and scratch what I said in the beginning of the video. You are going to be responsible for doing number 2 on your own and doing number 3 on your own. I'm going to go ahead and do number 4 because I want to work on one of the problems that have multiplicity to show you how to get that sketch done. All right. We're given zeros, -3 with a multiplicity of 2, and the other 0 is -1. And like I said before, if the multiplicity is not given, then that multiplicity is 1. Okay, so let's write this out. For the first 0, positive 1/3, we'll be writing that factor as x minus 1/3. Also, there's a multiplicity of 2, so we do need to raise that to the second power. And for our next 0, or our next 0 root or x-intercept, right, because they all mean the same thing, we were given -1, so we're going to write that as x plus 1. And the multiplicity is 1. We don't need to write the first power because we know it's there. Okay, let's go ahead and multiply this out. Again, remember that the whole point of multiplying this out right now is so that we can get the standard form equation of the polynomial. So first, x minus 1/3 to the second power, we have to rewrite that as x minus 1/3 times x minus 1/3. So we're multiplying it twice. That's what multiplicity 2 means. Times x plus 1. Okay. We're now going to FOIL the first 2 factors. Let me move this over actually. Okay. So we have x times x is x squared. X times negative 1/3 is negative 1/3 x. Negative 1/3 times x. Here, negative 1/3 times x is negative 1/3 x again. And negative 1/3 times negative 1/3 is positive 1/9. Simplify the middle terms because they are like terms. So negative 1/3 minus another 1/3 is negative 2/3. So we can write that as x to the second power minus 2/3 x plus 1/9. Don't forget, we have to multiply this with x plus 1. Okay. We're distributing again, so we're going to do x to the second power times both of these, one at a time. Then negative 2/3 x times both of these, one at a time. And then 1/9 times both of these, one at a time. X squared times x is x to the third power. X squared times 1 is positive x squared. Negative 2/3 x times x is negative 2/3 x to the second power. Negative 2/3 x times 1 is negative 2/3 x. 1/9 times x is 1/9 x. And 1/9 times 1 is 1/9. We're going to go ahead and combine like terms. So first you need to identify what terms are alike. We have positive x to the second power minus 2/3. And then we also have like terms negative 2/3 x plus 1/9. So in yellow, x to the second power minus 2/3 x to the second power is the same as doing 1 minus 2/3, right? Because the coefficient here is 1, and we're subtracting 1 minus 2/3, okay? 1 minus 2/3 is 1/3. That's a positive 1/3, by the way. And then you have negative 2/3. You're adding a 9th. Well, when you're adding fractions, they should have like denominators. So we have a denominator of 3 and a denominator of 9. Well, we can multiply this fraction by 3. That way they'll have the same denominator, which is 9. So 2/3, you would rewrite that as 6/9. So now negative 6/9 plus 1/9 is equal to negative 5/9. X. Let me write this fraction like this. Yeah, that's better. Okay. Also, I hope someone noticed this, but in yellow, when we did x squared minus 2/3 x squared, we got 1/3 x squared. I was supposed to put second power here. Okay. So sorry about that. And then lastly, we have 1/9 is the constant, or the y-intercept. And that is going to be our final polynomial function. Let's sketch. Going back to the beginning, we know that we had 2 zeros, or 2 x-intercepts, that were given to us, which is positive 1/3 and negative 1. So when we go to the graph, I'm going to start by plotting positive 1/3 and negative 1, just like we did in the previous example. So positive 1/3, zoom in, is going to be very close to 0. And then negative 1 is here. Okay, so there goes our 2 zeros on the graph. Now remember, positive 1/3 had a multiplicity of 2, which means that the graph is not going to go directly through 1/3 like this. It's actually going to go and touch 1/3 and come back in the other direction. Or it could come from here, touching 1/3 and going another direction. So one of these situations here, either this or this. And then negative 1 had a multiplicity of 1, so it's going to go straight through negative 1. Now we want to know what direction the graph is coming from and going toward. So we're going to look at end behavior. We're looking at a degree 3 again. And leading coefficient is 1 again. So just like problem number 1, we have the same exact degree and the same exact leading coefficient. So we know that we're looking on the left, our end behavior will point down, and on the right, our end behavior will point up. So let's get it done. On the left, pointing downwards from the 0 that we were given, the x-intercept, we're going to go straight through that x-intercept because negative 1 had a multiplicity of 1. So that means that I'm supposed to go through that 0. Okay? And then, oh, we know the y-intercept is positive 1/9. Remember I said that if you can plot the y-intercept, you have to. So let's go back a little bit. We also know the y-intercept is positive 1/9, which is a very small number. Yes. So we're going to go up, go through that y-intercept. Okay? We're going to touch the x-intercept of positive 1/3, but we're not going to go through it because the multiplicity is 2. So we're going to go right back in the other direction. And that is a sketch of our graph. So the 3 points that we have, negative 1 is the 0 that was given to us. The multiplicity was 1, so we went through that point. The y-intercept is 1/9. And the other x-intercept was 1/3, but it had a multiplicity of 2, so we're making sure that we do not go in this direction through that point. We're actually supposed to come, touch the point, and go back the other way. Done. Let's move on to number 5, 6, 7, 8, 9, and 10. So 5 through 10. This time you will be given the graph. We are given the graph, and we need to write the equation from the graph.